Hello, let's try a Leetcode problem today. Today we are going to solve number 50 power x to the power of n. So power xn. Yeah, basically we are going to calculate x to the power of n. Yeah, let's check the x and n first. So from here we know that x is more than minus 100 and less than 100. So this means x can be positive or negative numbers. And for this n, it is also a very large number. Yeah, it is basically 2 to the power of 31. Like this problem, we cannot use 2 like to the power of 10. We cannot use 2 times 2 10 times because if n is very big, it will be time limit exceeded. Yeah, so this is very clear. So we have to use another approach. So in this way, can we make the speed faster? Yes, we can. If n equals to 10 and x equals to 2, so 2 to the power of 10, why we not calculate 2 to the power of 5 times 2 to the power of 5? Yeah, so if we can calculate like this, normally this is a recursive function, and here we will use DFS. Yeah, because DFS is basically a recursive function. Let me first explain it in whiteboard and then go to the code editor. Yeah. Now let's go to the whiteboard first. So in the whiteboard, I've already make a drawing of two different cases because there are basically two different cases. One is x to the power of n. N can be odd number like 2, 4, 6, etc. Another case is n can be even number, so the even can be 2, 4, 6. Another case is n can be an odd number, so it can be 2 to the power of 3, 5, etc. Yeah, we are going to deal with different cases with odd number and even number. For example, if this number is n is an even number, 2 to the power of 2, and we know 2 to the power of 2 basically equals 2 to the power of 1 times 2 to the power of 1. Yeah, here is 2 to the power of 1. Yeah, and 2 to the power of 1, and then it can go to 2 to the power of 0, and then times 2 to the power of 0. But as you can see, if this n is odd, so 2 to the power of 1, the result is 2. But here, 2 to the power of 0, the result is 1. Here is also 1. Yeah, we know that 1 times 1 is still 1, but the result is 2. So from here, basically, we get the conclusion. If this n is an odd number, so the result will be this 1 times this 1 times this x. So x is 2 here. Yeah, so the result from here we get it is number 2. Similarly, here is also number 2, and here 2 to the power of 2. Yeah, it is 2 times 2, 2 to the power. 2 to the power of 2 is 4. But here, as we know this, here this n is an even number. If it is an even number, we don't need 2 times x. Yeah, so from here, we basically know our conclusions. It always depended on if this number n is even number or odd number. Yeah, similarly, from here, this side, if n is 3, so 3, we can divide it to 2 to the power of 1, 2 to the power of 1. So this 2 times, it means 2 to the power of 2. But that's not enough because this is an odd number. We have to time x, and the result is 2 to the power of 3. And 2 to the power of 1 similarly goes to 2 to the power of 0, 2 to the power of 0, but it needs to times this x equals to 2. Yeah, so this is basically all our recursive function. Now let me go to the code to make it more clear. Yeah, so we need to check the conditions. We can check it or not because the x, we can check this x value. So n is an integer, but this n can be 0. Either x is not 0. So if x is 0, Yeah, if x is not 0 or n can be more than 0. So from here we normally get to the conclusion is yeah, n is an integer. So this x is not 0. Yeah, because if this x is 0, n has to be more than 1. Yeah, as you know, if this x is 0, n is a minus number from mathematics, that is yeah, not right. So this is the case. So it can be either one of them. If n is more than 0, so yeah, x. Yeah, so this is contradictive. But basically, the idea is x. If x is 0, it is also okay. Now let me check the first condition. If x equals to 0, we can write this or not because our recursive function can also include these cases, but we can make it faster. If x equals to 0, we know the result should be 0 because 0 times any number, it is still 0. And then we define our recursive function. Let me make it DFS. So inside, I will still keep it x at n. And as here, we already know that this n can be smaller and smaller, but this n, the smallest, can be 0. So inside of the function, I will use x and n both positive, or n can be 0, but this n cannot be negative because I will, if this n is negative, it will be easier. It's just 1 divided by DFS inside the positive number. So if n is 0, we already know we can return a 1. And then inside, I will use a result as the DFS. So the inside, there are two numbers, x and n divided by 2. Yeah, and then result multiplied by itself, and we can return. So from the return, we need to check if this n is odd number or even number. So we can return result times this x. If it is an odd number, so the odd number is n modular 2. Else, so it will be the result. Now, I think we can return our function. So our function is xn if x more than 0. Yeah, because here I used x equals to 0. Yeah, we can make it yeah, x more than 0. Else 1 divided by this DFS x. So inside, yeah, here should be n because we are going to check this number n if it is positive or negative. For this x, it is okay. Yeah, yeah, because inside this x, for example, yeah, if this x is a minus number, it is still okay. Yeah, it does matter to the x, it's only to the n. If x is a minus number, here will be minus 2 times minus 2. It is still okay. Yeah, and here inside it will be minus n because n will be a negative number. Yeah, and here we only checked x, we don't know n, so n can be 0. If n is more than and equal to 0, we will directly use it, because if n equals to 0, we can return this one, return a 1. Yeah, now let me run it to check if it works. Yeah, if x equals to 0. Now let me submit it to check if it can pass all the testing cases. Yeah, it works. You know, the speed is faster. It's around 42%. Now let's change some of our functions. So as I said, I don't need to tag basically because this is a log n algorithm. Normally, we don't need to write this because if x equals to 0, it is still okay. We just need to check this n. Maybe we'll only need 32 times of calculation. It is still okay. Yeah, now let me submit it. Yeah. Now let's change a little bit of other testing cases. You know the speed, it doesn't matter. Now let's just check another cases. If here we use n more than 0, here we use else case. I think it is still okay because here if n equals to 0, we can directly get our result. Now let's just check it. Yeah, you see, it works. So my meaning is we can write any function as we like, but the core idea is about here, how we should understand this basic recursive function. Yeah, and what will be each step and what will be the return of the function. And then we can get our idea. So the code is not important, the ideas are important. Thank you. If you like this video, please subscribe and like. I will upload more Leetcode problem next like this.